G'day, this is Dr. Peter Price of Classroom Professor. Welcome to this video. The topic this week is division with remainders and dividing by 5 and by 10. This comes from this book, which is our 10 minutes a day level 3, book number 3, division with remainders. So this is for grade 4 students or year 5 in Australia. So we're looking at division as an operation. That's the fourth operation that we will do. But this book, this set of strategies, comes after students have done ordinary division, if you like. So they've done all 4 operations: addition, then subtraction, multiplication, then division. And now we get to division with remainders. And I would recommend that we treat that separately. And I know that in the curriculum documents it's treated separately. So it's basically a year after the students have been expected to know all their basic division number facts. So we're dividing by 5 or 10, which of all the divisors are 2 of the easiest ones. 2 is probably a little bit easier, but 5 and 10 come right after that. And we've bundled them together on the same set of worksheets because dividing by 10 is relatively straightforward, so we can add 5s to it. And of course 5 relates to 10. So we've got a couple of examples written on the whiteboard. Dividing by 5, we've got 20, then 25, then 30. Those, of course, are multiples of 5 or whole multiples of 5. And so these should be well-known number facts to our students. But between them, we have other numbers. And so our students need to realise, and of course we'll help them understand this using materials and so on, that if we have a number between the whole number multiples, we can still divide it by 5, but we'll just have some left over. So dividing 21 by 5 means we're going to have 4 collections, if you like, depends on the model that we're using for division. 4 lots of 5 and 1 left over. I don't particularly care how students record that. I mean, you want consistency in your classroom, but whether you write a capital R or a small one or an REM, or it doesn't really matter. And then, of course, the next will be 4 remainder 2, 4 remainder 3, 4 remainder 4, and then we get to 5. You know that, I know that. But we want our students to see the patterns that are involved here. So this might be a nice exercise for students to do. Record a sequence of numbers like this. Now, I've picked this sequence, as you can see, basically out of the middle of the 5 times number facts, and ask them to record the answers to each one of the each one of the numbers divided by 5. They should see there's a pattern there. You could talk about what the remainders mean. You could talk about the fact that the remainder here, the remainders are 1, 2, 3 and 4, and that one doesn't have a remainder. And then we have remainder 1, 2, 3 and 4, and then that doesn't have a remainder. And we could ask the students, you know, what's the biggest remainder you can get? If you're going to divide by a number and you're going to have a remainder, what's the largest remainder? Of course, if we're dividing a whole number, the remainder will be 1 less than the divisor. That will be the biggest. So when we're dividing by 5, we may have a remainder of 4, but of course we can't have a remainder of 5. Okay, so these are relatively straightforward. You could use 10 frames with these simply because the 10 frames show 2 rows of 5. And so that would be a nice way of showing multiples of 5 and then some left over. So there again, 10 frames once again come to our rescue, I suppose. Looking at dividing by 10, this is even more straightforward. Now we have more possibilities for remainders. Obviously we've got remainders from 1 to 9 this time, 9 being the next number below 10. But dividing by 10, as we all know, is really straightforward. Of course, we would discuss this with the students. We would ask them why it's straightforward, why is it so easy? And in this case, you could use base 10 material. So if you had, say, for example, 54 using base 10 blocks, obviously you'll have 5 10 blocks and 4 left over. What's the significance of that? Well, if we're dividing by 10, one model is to say how many 10s can we take away, repeated subtraction. We can take 5 10s away, what's left? 4. What do you notice about the number that you started with? Well, we started with 54. We divided by, whoops, I need an equal sign, divided by 10. The answer is 5, remainder 4. What do you see? What is, what is the same about the answer in the question? Well, we've got a 5 here and a 5 here and a 4 there and a 4 there. Why would that be? And of course, it's all about the fact that our numbering system is a base 10 numbering system, which means we collect tens. And when we collect a group of 10, we count it as 1 10. And we get an extra 1 in the 10 column. So the 5 in the tens column means 5 collections of 10, etc., etc. So there's a really nice connection here between place value and the dividing by 10. It's a pity they aren't all this easy. Dividing by 10 is obviously one of the easier divisors. Then we can move on, as you'll see on the worksheets, we can look at larger numbers, and so there are some further examples on the worksheets of 3 and 4 digit numbers to divide by 10 with remainders. And at first glance that looks, a little bit challenging. They're a lot larger than the numbers we normally see on a basic number facts worksheet, but it's purely because we're dividing by 10. So again, we can see that 38 divided by 10 will have a number of tens and then some ones left over. How many tens are there? Here's a chance to emphasize the fact that we can isolate a sequence of digits like that and call it by the name of the last place. So in other words, 384 can be seen as 38 tens and 4. And of course that gives us our answer, 38 divided by 4. What I would not recommend, and if you've watched other videos of mine, you may have heard me say, don't move the decimal point. We're not talking about having a decimal and moving it or any such thing like that. We're saying how many tens are there, and we want to look at the symbols and see where the tens place is, how many tens are there. This one's easier, it's only got 1 digit, there are 7 tens, it's 7 tens and 9 left over. This is a bit harder because of the 0, but of course again, if we're following the same sort of protocol, we could do that there and say that's the tens. Here we have some tens. And in the 4 digit number, here we have some tens. And I'm recording the T only here just to emphasize the fact this is the last of the 3 places. This is the last one. This is the tens place. But we can now read this 3 digit number as a number of tens. 115 tens and 6 left over. And this one here, even though there's a 0 there, it's not that hard. We have 50 tens, remainder 2. Okay, so division with remainders will take some time. My recommendation would be to do the sorts of things that I've just illustrated on the board, where you explore the numbers and you use base 10 materials and you use the 10 frames and you ask the children to explain what they can see. Far better they do that than we just say, here is a lockstep method. Follow the steps and you'll get the right answer even if you don't understand it. That wouldn't be what we would recommend. Okay, so we've come to the end of the video. I hope you've enjoyed it. I look forward to talking to you next time.